Now let's continue on magnitude of the vector. Now we have 7 questions here. We have that if A is equals to 6, 3, B is equals to minus 4, 2, C is equals to 11, 5, D is equals to 0, minus 3. We should evaluate the magnitude of the following vectors. And we can see individual vectors that involve scalar multiplication, and we also have vectors that involves scalar multiplication combined by addition and subtraction. All right, so to make my first, let's make this one negative. All right, so we know the rule of magnitude of vectors. We know that if R is equals to xy, the magnitude of the vector is equals to square root of x squared plus y squared. That is the square root of the sum of the individual squares. So let's begin with A. A is equals to 6, 3. Therefore, the magnitude of A will be equals to the square root of 6 squared plus 3 squared. And that's the square root of 36 plus 9. The square root of 36 plus 9 is equals to 45. That's root 45 units. And if you want to leave it in decimal form, root 45 is equals to 6.708, approximately to 3 decimal points units. Let's move on to question 2. We have B is equals to minus 4, 2. So the magnitude of B can be written as the square root of minus 4 squared plus 2 squared. So this will be equals to the square root of 16, okay, plus 4. That's root 20 units. Similarly, question 3, which says we should evaluate the magnitude of the vector 2c. 2 and the vector of c, which is 11, 5. 11, 5. Now, if you take the scalar multiplication of this, we have 2 multiplied by 11 and 2 multiplied by 5. And this will become 22 and 10. So we can evaluate the magnitude of this now and say the magnitude of 2c is equals to the square root of 22 squared plus 10 squared. Let's move this downward. Okay, and 22 squared is equals to 484 and 10 squared is 100. So this will result into 584. And if you take the square root of 584 with a calculator, you will have 24.166 units. Okay, so now let's get question 4. Question 4 says we should evaluate the magnitude of minus 4d. Question 4, which is minus 4d. So that's minus 4. The d vector, the vector d, is equals to 0, minus 3. 0, minus 3. So if you take the scalar multiplication of here, or 4 multiplied by 0 minus 3, we have minus 4 multiplied by 0, minus 4 multiplied by minus 3. So this will result into 0 and 12. So therefore, the magnitude of minus 4d as a vector is equals to the square root of x squared plus y squared. The x in this case is 0, that's 0 squared, and 12. The y in this case is the 12 plus 12 squared. So this will result into 0 plus 144, and this will result into square root of 144, which is equal to 12 units, because the square root of 144 is 12. Moving on, let's evaluate for question 5. Question 5 says we should evaluate the magnitude of 2a plus b. Magnitude of 2a plus b. Now, 2a plus b, what is our a, what is our b? Our a is 6, 3, and our b is minus 4, 2. Our a is 6, 3, okay, and our b is minus 4, 2. Now, we can simplify the scalar multiplication here, and this will become 2 multiplied by 6. Okay, and this will become 2 multiplied by 3 plus minus 4 and 2. So this will result into 12, okay, and 6 plus minus 4 and 2. And when we take the addition of this, we'll have 12 minus 4, that's 8, and 6 plus 2, which is also 8. So we have 2a, okay, 2a plus b to be equals to 8. Therefore, the modulus of 2a plus b will be equals to the square root x, this is x, and this is also y. The square root of 8 squared plus 8 squared. 8 squared is equals to 64, so 64 plus 64, which is equals to 128. And the square root of 128 can be written as 11.314 units.